Hello, class. This is going to be the last section for this week, so you can take your time. I know today's only Tuesday, but in case you're running ahead, here's 3.2. I will not do any more lesson plans or videos this week because, it's important to look at that syllabus to know what's expected. And for this week, we end with section 3.2. So this is Math 1430, section 3.2, product and quotient rules. So here's our first problem. If f of x is equal to this product, 3x squared minus 7 times x cubed plus 2x, find the derivative f prime of x by the product rule. So what is the product rule? Here it is in words. The product rule, and by the way, there's 8 variations of the product rule. So if you learned it a little differently, that's fine. You don't have to do it my way. So here's the way I'm going to do it. It's going to be the first factor times the derivative of the second factor. So first, exactly as it appears, times the derivative of this second factor, and then it's always plus, no matter what variation you use. The product rule always has a plus sign, and then it's going to be the second factor, exactly as it appears, times the derivative of the first. So that is the product rule, which is proven true. This will work to give you the derivative. Here's a common mistake, to just go derivative times derivative. No, it's not that simple. The product rule, in order to work, you got to do it in this form or some form thereof similar to it. So I'm going to go first times the derivative of the second plus the second times the derivative of the first. All right, so here we go. So I'm ready to start this. So let's begin by writing f prime of x equals. That is very important. That's another common mistake, just to write down the answer without saying what that answer is. This is the derivative function, so denote it, f prime of x equals. And it's going to be the first, which is 3x squared minus 7, times the derivative of the second. So this is just a sum here in the second factor. So the derivative of a sum is the sum of the derivatives. So just go derivative plus derivative. What's the derivative of x cubed by the power rule? You bring down the 3, keep the base, decrease the power by 1, and then plus the derivative of 2x is just the number in front of x, which is 2. So there is the first times the derivative of the second. Don't stop there though. Plus the second. So the second factor is my x cubed plus 2x. And that's going to get multiplied by the derivative of the first. So first times the derivative of the second plus second times the derivative of the first. What's the derivative of this first factor? You bring down the 2, it multiplies the 3, so it's 6x to the first minus 0, which is simply 6x. I'm just going to write 6x. You don't have to write minus 0. That doesn't change anything. So there it is. Okay, and then you want to simplify. So let's multiply this out here. So 3x, I'm going to do the FOIL method for these first two factors, and this is considered one term. Terms are separated by pluses or minuses. So with this first term, I'm going to FOIL it out. First, outer, inner, last. 3x squared times 3x squared, those are the first terms. That multiplies to 9x to the fourth. You add the exponents when you have the same base. And then the outers, 3x squared times 2 is plus 6x squared. And then the inners, a minus 7 times 3x squared is a minus 21x squared. And then the last terms, minus 7 times a plus 2 is a minus 14. So try to get your signs correct. Okay, so double checking that. First, outer, inner, last. Good. And then it says plus. With plus signs, you can really relax. You don't have to worry about, changing of signs. You don't have to worry about putting parentheses. Plus signs are really a beautiful thing. So to get this simplified, this term here, to simplify this term which has two factors, I'm going to distribute the 6x. Don't do the FOIL here because this is a binomial times a monomial. So I'm going to distribute the 6x. So what is the 6x times the x cubed? And then what is the 6x times the 2x? So 6x times x cubed, remember x is like x to the first. You add the exponents. to get 6x to the 4th. Get those exponents correct. Plus 12x squared when I distribute. So 6x to the 4th plus 12x squared. And then finally, let's collect the like terms. So this is an x to the 4th term. Do I have any other x to the 4th terms? Yes, those are like terms. So what are 9 of them plus 6 of them? 15 of them. So write 15, and then you keep that x to the 4th, because we're just adding like terms. So you're going to have more of those like terms. Okay, so 15x to the 4th. And then I always like to go in a descending order, standard form. 4 was my highest exponent. I don't have any cubes. How about that? No cubes. So let's go to the square terms. So I'll double underline my square terms. So here's a 6x squared minus 21x squared. So that's going to be a minus 15x squared. Minus 15x squared plus 12x squared is a minus 3x squared. It's a minus sign here. Okay, and then do I have any x terms? No. The only term I have left is the minus 14. Minus 14. And that's it. We're done. I'll put the little block here. Done. So that's my final answer. That is what the product rule gives us for the derivative of the original function f. And this will tell us, for example, the slope of the tangent line for any x on the graph of this function. And slope of tangent line is the same thing as saying the instantaneous rate of change. So again, whenever you're asked to find slope of tangent line or instantaneous rate of change, derivatives are called for. Okay, let's go to the second problem. And this is going to be the quotient rule. So I'm giving one example of the product rule. We just did that. Now I'm going to give you one example of the quotient rule. So if y is equal to this quotient, 3x minus 2 over the square root of x, find y prime. So this time I'm giving you a different look. Instead of f of x and f prime of x, I'm giving you y and y prime. Same exact thing. So we want to find the derivative. That prime means derivative. And we're going to do it by the quotient rule since I see a quotient here. So here's the quotient rule in words. It's kind of a fun way to say it. It's going to be low d high minus high d low all over low squared. So low means the denominator. D means take derivative of. So I'm going to go the denominator times, this is all multiplication here, so it's the denominator times the derivative of the numerator is high, minus, so notice the quotient rule always has a minus sign, whereas the product rule had the plus sign. And you're allowed to use your notes for these upcoming tests, so make sure you have all these rules written down, so that way you can do better. Okay, and then it's going to be minus high d low, so that really means numerator times derivative of the denominator, d meaning derivative, all over the denominator squared. The order matters, by the way, with subtraction, so make sure you always begin with low d high minus high d low. The most common mistake is to do the high first, but you can't do that because subtraction, the order matters. So the way I like to think about it is, when you see a quotient, you feel pretty low because it's a lot of work. So low d high minus high d low all over low squared. So let's use this formula. So before you jump into the derivative, always ask yourself, can you simplify the original function so the derivative will be easier? And the answer is yes. Let's get rid of that radical. You always want to get rid of radicals when you're going to do derivatives or integrals later. So isn't the square root of x the same thing as x to the 1/2? So still y, because I have not taken a derivative yet, still y, just rewrite it as 3x minus 2 over x to the 1/2. Now I'm ready to take the derivative. So from here, I'm going to write y prime equals, because I want to announce to the world I'm doing a derivative here. So y prime equals, and here I'm going to go low d high. Low is x to the 1/2, that's my denominator. So it's low times the derivative of the numerator, which is just 3. Low d high minus high. Here's a common mistake here, to write the high like this. Do you know what I did wrong? You must use parentheses. Parentheses abound with these product and quotient rules. It's all of high. All of high. times the derivative of the denominator. So I'm going here, I'm going minus high, all of high, use parentheses, times the derivative of the denominator. So I'll write a little raised dot for times. What's the derivative of x to the 1/2? Use the power rule. 1/2 x, and then 1/2 minus 1 is a negative 1/2. And then you always want to simplify. Let's simplify this. Oops, what did I forget? Over the denominator squared. So before you simplify, make sure you get that derivative correct. All over x to the 1/2 squared. This is not a negative sign. Let me clean up the board a little bit. I'll be right with you. Okay, so this is x to the 1/2. Try to make your exponents high so they look like exponents. This is not a great looking exponent. Okay, and then it's going to be all over. Oh yeah, this is not a minus sign. Let me get rid of that. Okay, all over the denominator squared. So let's simplify this. Equals, put the 3 in front. And then you can either write x to the 1/2 or square root of x. They mean the same thing. I'll keep it as an exponent since my original problem just had exponents. Okay, and then it's going to be, let's see, what's the best way to do this? For now, I'm going to write minus. I'll put this is all one term here. It's all multiplication. So put the number first. So minus 1/2. And then I'll write x to the 1/2. And then we got times in parentheses the expression 3x minus 2. All expressions go in parentheses. And that's going to be all over. So a power to a power, you multiply. So know those exponents rules. 1/2 times 2 is 1. So x to the first is just x. I'm just going to write all over x. Okay, this still needs to be simplified. If you want to, you can bring down the y prime, but you don't have to, because if you just bring down the equal sign, that's understood to be still y prime. Okay, let's see. I don't like this 1/2 in the numerator. That's not considered simplified. You shouldn't have fractions in the numerator or denominator. So what I'm going to do is multiply this whole numerator by 2 and the whole denominator by 2, because this is like another name for 1, 2 over 2. This is my only little denominator, so that's like my LCD. So this is now going to equal, so distribute this 2. 2 times the 3x to the 1/2 is 6x to the 1/2 minus, and then 2 times a half, they go away, because 2 times a half is 1. So what's 1 times x to the 1/2? It's just going to be x to the 1/2. And then don't forget that other factor of 3x minus 2. So when you have factors, just multiply the first two together and then rewrite the other factors. We're not distributing this 2 with this, and that, because there's no pluses or minuses. You only distribute with pluses or minuses. And that's going to be all over 2x. And I suppose I should distribute the x to the 1/2. So let me continue. This will be my last step. So this is going to equal 6x to the 1/2 minus, and now distribute x to the 1/2. So x to the 1/2 times 3x is going to be a 3x, and you add the exponents. So 1/2 plus 1 is 1.5. 1.5 as an improper fraction is 3/2. So 3x to the 3/2. So 1/2 plus 1 is 1.5. 1 and 1/2. And then here's how you write it as an improper fraction. You go the denominator times the whole number plus the numerator. So 2 times 1 is 2, plus 1 is 3. And then you keep that denominator of 2. Okay, and then what is the x to the 1/2 times the negative 2? And don't forget, it's minus x to the 1/2 times this. So we're going to have to write plus 2x to the 1/2. Make sure you write plus all over 2x And if I wanted to, I could pull out an x to the 1/2 from the numerator and simplify it with this x downstairs, but this is good enough. It could be simplified a little bit more, but I'm going to stop there because this is already 15 minutes long. Okay, so good night, everyone.